Okay, good morning, guys. I am homesick today. Hopefully, I'll be back on Friday. We don't have class again until Friday after this. So, in the meantime, I'm going to do my best to try to record a lesson. I could not figure out how to record on Classroom or Class Meets, Google Meets. The record button isn't there like it is on the computer there at school. I have to use my iPad because my computer crashed, so I just have my iPad. So we're going to use YouTube. Hopefully everybody can download this and watch it, but I'll upload it to Classroom. So, okay, so we're looking at section 5.3 today. And section 5.3 has three main theorems that we're going to look at. Four, I guess, main theorems. One is just the repeat of the other one, only backwards. They have to do with parallel lines. So, I guess I could set this down. So the first theorem is if two lines are parallel, then all points on one line are equal distance from the other line. Well, we know that parallel lines are always the same distance apart all the way down, so that makes perfect sense that the points are going to be the same distance from one line to the other. And then, but that's just basically as a theorem, that means it's just guaranteed that if you know the lines are parallel, then you know the points are equidistant if they're drawn from one point to the other. The second theorem, theorem 5.9, if three parallel lines cut off congruent segments on one transversal, then they cut off congruent segments on every transversal. Basically, what's that saying is if three parallel lines are the same distance apart, if the third line is the same distance from the second and the first line, then it's gonna be that way all the way through. So I'm gonna draw a picture of that. We're gonna try anyway. So what that one is saying is, and this is going to be interesting because I have to hold my camera and try to draw at the same time. What that one is saying is that if I have three parallel lines, okay, so this may not work. So I have three parallel lines, 1, 2, 3. If I cut a transversal here, and I know that this length is the same as this length, then if I know that, then I know that any transversal that I draw, this one's going to be the same length as this one. Now, not necessarily equal to each other, because the slant may be different, but I know that this one is equal to this one. If I know one is, then I know on every transversal line that those lines are the same distance apart. So that would be true even if I drew another line down. If I knew that they were the same distance apart on one transversal, I'm going to know that they're equal distance on all the transversals. Okay, so a problem that might include that would be let's see here. Would be like, for instance, let's say, let me turn this around again. Let's say that we know that, like, if I know that this one is 5, then I know that this one is 5. If I know this one is 6, then I know this one is 6, and so on. But if I drew that third line there, and I know that it's also equidistance, then if I told you that, like, say, this is A, B, C, D, and you know that they're equal distance from each other, and I tell you that AB equals 6, and I want to know what AD equals. Well, AD is 1, 2, 3 of those, so that would be 18. So you could find that length by knowing that those are all the same distance apart. Okay. So the next one has to do with midterms of a triangle. So I need to erase this. So if I have a triangle, I'm going to go ahead and draw the triangle before I pick the camera up. But if I have a triangle, and I have a line going through the triangle that I know, the first theorem says a line that contains the midpoint of one side of a triangle and is parallel to another side of the triangle is going to have the midpoint of the third side. So what I have here is, let me turn this around now, I got the picture drawn. If I know on this triangle that this is the midpoint of this side here, and I know that this is parallel to this, then I also know that this is the midpoint right here. So it's telling you that if you know the two lines are parallel and you know that it's hitting the midpoint on one side, then it's going to hit the midpoint on the other side. So by midpoint, that means that I now know that this side, this equals this, and this equals this. So if you're given that it's the midpoint on one side and you're given that it's the parallel to the third side or to the other side, then you know it's hitting the midpoint on the third side. That's the theorem. Now, theorem 511 is just the opposite. If you know that it's hitting those two midpoints, so you're given that this is the midpoint here and this is the midpoint here. If you know that that's the midpoint, that it's hitting the midpoints on the two sides, then you know that it's parallel to the side on the bottom. Also, you now know that that segment right here from A to B is going to be 1/2 of the line at the bottom that it's parallel to. So AB is equal to 1/2 of CD. So that comes in really handy. If you know those are the midpoints, then you know it equals 1/2 of the base. Okay. So we're going to work on some problems here. I'm not going to make you do any theorems today just because of the, you know, how it can be so complicated. I'm going to draw another picture. So I'm going to set that over there. I hope everyone's doing okay today. Oh, sorry you had to see that. I don't know if I'll ever get used to seeing myself on video so much. I just don't like it at all. But okay, so this triangle, it's going to go, after I get it drawn, I'll put it up there and let you guys have a chance to draw it out. Okay, and we're going to go from the midpoint here. Okay. Hope everyone had a good weekend. I was sick all weekend. I do have to go today to get tested so that I can come back to school. I don't think I have a COVID. I think I just have a really bad chest cold, but it's still good to get tested in this day and age. So here's the picture. Okay, so each one of those is going to be given to you that the M, the N, and the T are all the midpoints. So if you know that those are all the midpoints, then you know that TN is parallel to XM or XY, and you know that and TM is parallel to ZN or ZY, and you know that NM is parallel to ZT or Z or TX, any of those on that side. So you also know that each of those pieces is equal to each other and so on. So I can't figure out how to adjust my camera so that I can make this better, but so in this picture what we're going to do is we're going to start out by saying that XZ or XZ. Okay, so I see. So XZ is going to equal 10. So we want to know what MN equals. Okay, so if XZ is equal to 10, then MN, let's see here, MN TX. Okay, so MN is going to be the midpoint of this line to this line, and then it's going to be from here to here. This is your baseline. So if we're just looking at the big triangle, sorry, we're looking at the big triangle, and then this line is hitting midpoint to midpoint, then this line is parallel to this line, and this line is 1/2 of this line. So if XZ is 10, then MN is 1/2 of that, which is 5. So you have to see that that's the one that's going from midpoint to midpoint. Doesn't really look like it, but it is. So, it's supposed to be anyway. Okay, so then the next question is, if TN equals 7, then XY equals, okay, so TN is from here to here, so that's going the midpoint going this way, so it's going to be 1/2 of this bottom piece right here. So XY is going to equal twice TN, so it's going to be 14. Okay. So suppose that XY equals 10. So we're going to do a new problem here. We're going to say that XY equals 10. And X and YZ equals 14. And XZ equals 8. So that's the lengths of all the sides of the big triangle. What are the lengths of the 3 sides of triangle TNZ? So triangle TNZ is from here to here, up here. I need colored pencils. So it's that one there, that top triangle. So if we know that ZX equals 8, then we know that ZT, so we're going to, well, let's start out with just TN. So TN is this line here, so it's 1/2 of XY. So TN equals 5. And then we're going to do NZ. So NZ is 1/2 of, so here's NZ, so it's 1/2 of, let's see, it's 1/2 of ZY. So ZY is 14, so that's 7. And then we're going to find TZ. So TZ is here, and it's going to be 1/2 of ZX, and ZX is 8, so that's going to be 4. So each one is just 1/2 of the other one. Okay, so let's see. So I'm going to erase that picture. Let me just kind of hold it up there for a minute in case some of you guys are still writing all that down. So you're mostly going to be finding lengths of sides and just using those rules that I've given you and finding lengths of sides. From what I can tell, the majority of the questions are going to have to do with the midpoint theorem, with the fact that the midpoint is, if you connect to one midpoint of one side and you're parallel to the bottom line, then you're connecting the midpoint on the other side, and that line going through the triangle is 1/2 of the base if it hits both midpoints. And then the other, I know that also brings into play the one with the parallel lines where the transversals have equal parts. Those are going to be the main questions that you're going to have. So, okay, so I'm going to erase that. I'm going to draw another picture. Okay. So I don't know who your sub is this morning, so they may or may not know anything about geometry. If you're lucky, they will know something about geometry, and then you will be able to get them to answer your questions. If not, you can send me a text, or I can answer questions on Friday. I'll be glad to spend some time on Friday going over questions that you might have. So, okay, so we're going to do one that has the parallel lines, just to kind of look at some of the questions that they might ask with that. So I'm going to draw what might appear to be parallel, or what won't appear to be parallel lines, but what I'm going to say is parallel lines. These are all going to be equal distance from each other. So we're going to have A, B, C, and D. So if I know that AC, I'll show you the picture in just a minute. I want to get this written down. If I know that AC is 12, then CD is equal to what? So here's this is the kind of questions that you're going to get from this type of thing. So if I know that AC is 12, and I know that these are equal to each other, because that's been told in the directions, or the things will say that AE is parallel to so on and so on, that the lines are parallel to each other, and that AB is equal to BC is equal to CD, and so on. They're going to tell you that. So if I know that, then AC is 12, then CD is going to be half of that, because it's one of these, and AB is two of these. So CD is just going to equal 6. So there'd be some questions similar to that, but they'll also do stuff like, okay, let's say that AC equals, you're going to have your algebra in here, 22 minus x, and let's say that BD equals 2x plus 12, and we're supposed to find x. Okay, so AC is 2 lengths and BD is 2 lengths, so that makes them equal to each other. I thought maybe it would be one that wasn't equal to each other. So we're just going to set those. Oh, I got off on the wrong track. Let me see. Will that come out right? Give me 3x and 30. Nope. Okay, so this was supposed to be, sorry, BD was supposed to be 3x minus 22. Okay, so we just set those equal to each other because AC is 2 lengths and BD is 2 lengths, so we can just set them equal to each other. So 22 minus x is equal to 3x minus 22, so we'll add x to both sides. So 22 equals 4x minus 22, add 22 to both sides, and 4x equals 44. So x equals 11. Oops. Okay. So now you might have a problem that says, let's say that AC equals x plus 5, or 2x plus, let's go with 2x plus 10. And then we know that, and then we'll say CD equals 3x. Well, that doesn't make sense because it's smaller, so let's just go with x. Oops, sorry. I didn't realize I wasn't showing you. Okay, so AC is equal to 2x plus 10. And so let's say CD is equal to x plus 4. Then, let's see, we can't do that. Okay. 2x. Well, this isn't, okay, wait, I gotta set this down for a minute. So if AC equals to 4x plus 16 and CD equals x minus 6, then CD is half of AC. So in order to set these equal to each other, we're going to have to take the x minus 6 times 2. So we're going to have 4x plus 16 equals 2 times x minus 6. 4x plus 16 equals 2x minus 12. And this may not make sense because we're going to get a negative answer. So this is the problem when I try to make things up myself. So it gives me 2x equals a negative 28 and x equals a negative 14, which doesn't make sense because that would make the lengths negative. But if I turn that around and I change this to a minus, I'm sorry, you guys. I probably should edit this out and just start over again. Not sure if I know how to do that. So if we change this to a minus 16 all the way through, then it's going to make more sense. Okay, so then 2x, we're going to subtract 2x from both sides, and then we're going to add the 16 to the other side, which is going to give me a 4. So then x equals 2. That makes more sense. So, sorry about that one. But what I wanted to show you there was if you have one like that where AC is 2 lengths and CD is 1 length, you're going to have to take the second one times 2 in order to have them equal to each other. So, okay. So let me see here. Okay, so I'm going to do one more, and then I'm going to let you guys get to work. Okay, so this is just going to be a simple triangle with the thing going from midpoint of one side to the midpoint of the other side. Okay, so in this problem I have 4, let's see, x minus 2y So I'm going to have 2y plus 3 equals y plus 7. And I'm going to have 4x plus 5 and 12x talking to myself, sorry. Minus 0. Okay. So this is the picture. I'll give you a minute to write it down. So the line is going from, the way I would know this would be if I just said that this is parallel to this. If the picture says that those are parallel, then you know that those are the end point, they're the midpoints. It's a distorted picture because it certainly doesn't look like it's the midpoints, but we're going to say it is. So with this one, on the right-hand side, I think that line just really needed to go up just a little bit, but because that's supposedly the midpoint, then that means that 2y plus 3 is going to equal the y plus 7. So you're just going to solve that. So you're going to subtract y from both sides, and then subtract 3 from both sides. So y equals 4. So that was easy enough. Because I told you that was a midpoint, then you have to go with the assumption, even though it doesn't look like it, and if you got out your ruler, it probably wouldn't be, but 2y plus 3 equals y plus 7. And then the other one, the 4x plus 5, that line is supposed to be half of the 12x minus 14. That's where I really don't see where this is lining up right. But that means we'll do what we did before. We're going to take 2 times 4x plus 5 to equal it to the 12x minus 14 because it's half of the side. So we're going to have 8x plus 10 equals 12x minus 14. Subtract the 8x from both sides. I've got 10 equals 4x minus 14. Add 14 to both sides. I've got 24 equals 4x, and x equals 6. So you're going to have some problems like that. So, okay, so I will put this you will find, you're going to find this if you're watching it, you've already found it in the classroom, and the assignment. But the assignment is going to be on page 180. This is 5-3, page 180, and it is going to be 2 through 16 even. I'm not going to have you do any proofs today. We'll look at those when I come back. So, okay. I also will probably have a quiz on Friday if I come back. So just study I think the quiz would be over 4.7 through 5.3. Just go back and study those and look at the self-test on page 182. But the main thing is, like I said, when I come back, I will go over any questions you have. Even if we have to spend the first 15, 20, 30 minutes going over that, that's what we'll do on Friday. And then to make sure you understand all this, and then we'll have the quiz, and then we'll go over the next section. So that is the last problem, and I hope to see you on Friday, but I'm going to go get tested, so I'll talk to you later. Bye. Be sure you text me. Most of you have my phone number, but 319-470-3113 if you're having trouble. So, and I will try to answer you. Okay, we'll see you later.